Okay, hello everyone. This is question number 6 from the midterm, and we're gonna try to solve it now. So the question said, what are the concentrations in the stock and in the final tubes based on the serial dilution scheme? You are told here that you will, from the stock solution, you transfer 1 ml to the next one, and then from that you mixed it and you transfer another ml and so on. You are told the only concentration that you know is this one here in the middle, and you are told that is 2 millimolar. And then here in this rectangle here you are told that each tube has 4 ml solution before starting the dilution. Can be tricky because it's not explicitly stating that it's before doing the dilution, but that's how you have been taught so far in the class, so that's how you have to solve this in particular. But you are always free to ask if that's what it means, if those 4 ml solution in each tube is before adding that extra ml or is after that. So with that information in mind, we will draw the scheme again here. So we'll write the one that we know. So this one is the one that is 2 millimolar, and then 1, 2, and 3, 1, 2, and 3 more, and you're told that there have 4 at the beginning, and then you're passing. We don't know how much this one, the initial one, has, but you know that you're adding 1 to each of them. So it's 4, 1, 4, 1, 4, 1, 4, 1. So the first thing that you have to solve for this, and this one you don't know, and this one you don't know. The first thing that you have to notice here is the dilution factor is 1 in 5 total. So then you know that from here to here you diluted 1 in 5, 1 in 5, 1 in 5, and from here to here 1 in 5. And then from this one the same, 1 in 5, 1 in 5, 1 in 5. So with this the reason why I'm doing the scheme here is because with this you're able to do really quickly the dilution factor from here to here, and the dilution factor that you use to get this concentration, but here is amplifying, right? Because it's getting more concentrated because it's the original, this one, the stock, concentrated, more diluted. But all of that is in reference from this middle one that is the known solution, and this is each of the dilution factors. So from here it is pretty straightforward to know the concentration of the stock solution. We have to see how many times you diluted before the 2 millimolar. So you diluted 1, 2, and 3, and if you multiply this, is equal to 1 over 125. But you know that for this you're not diluting in this way, you're concentrating, so you have to multiply by the inverse of the dilution factor. So if you had 2 millimolar in this known concentration here, you just have to multiply it by the inverse of the dilution factor. So that will be 2 times 125, so it's 250 millimolar. So that is the concentration of the stock. Now let's go for the diluted one. For the diluted one, you know, again, you diluted 1, 2, and 3, and you already know that when you do that 3 times dilution 1 and 5 is 125, but in this time you were diluting, so then now you again start from 2 millimolar, but now you have to multiply directly for the dilution factor, that is 1 over 125. So then it's 1 here, and then this is equal to 2 divided by 125. This is equal to 0.016 millimolar, and this is the final. And then we go back to our alternatives, and we have actually only one that has the 250 millimolar here. For some reason that doesn't match. But this one doesn't match because it's telling us 0.05612 there, but so this is not correct. So we have to look, maybe we have to notice that they're playing around with the units, so B is not because of that. And then we have to convert. They're expressed in molar, so we know here 250 millimolar, we have to divide it by 1,000, and then it's equal to 0.25 molar. So these two are equivalent. And then the other one, so let's see if there is any that is like that. So yes, C could be. So let's prove that this is can be correct. And because it's micromolar, the alternative that we are giving is 0.0616 millimolar. That is this one here. 0.016 times 1,000 is equal to 16 micromolar. So actually now we can confirm the correct answer was C. Okay, thank you, bye.